Hello and welcome back. Today we talk about how we can handle big data in OpenBIS, in particular how we can link data that is stored externally using a web-based tool. As a reminder, why are we talking about this? OpenBIS handles all of our metadata, so we can describe experiments, samples and so on, but large data sets or big data need to be stored externally on the codes in S3. So in order to relate the two, we need to link the files that are stored on the S3 storage to OpenBIS. In order to get the linking tool, first of all, it's best to have one instance running per institute. So please get in touch with your IT admin of your institute and see if they can provide a web service, or you can run it locally on your machine. So you can clone the RDM repository, set up your local environment using Poetry, and then start the web app in your environment. It's a Streamlit app that you, after you've activated your environment, can run with Streamlit Hello API. The first step, before you can link any data, you need to create the element in OpenBIS that you want to link it to. So for example, you create an experiment and here you link the relevant data to. So we also need an authentication token from OpenBIS. So after you log into OpenBIS, you go to your user profile and get this alphanumeric password replacement. It's essentially a string that lives for a number of hours. And then you can use this instead of a password to log into the service. As before, when we use the Python script, we need a number of details that we need to specify. Of course, we need the session token. We also need the a personal access token to authorize ourselves against OpenBIS. We need the OpenBIS in S3 configuration as project AO7 for help. You need to think of a prefix that is optional that you want to prepend all your files to. That helps make all your files unique in the S3 storage space. Of course, you need the file or the files that you want to link and the identification string where you want to link the file to, but this is also then handled by the web page, but you at least need the experiment that you want to link to. You need to specify the type of the data, and if a metadata extractor is already available, that will be shown to you. And you can name the linked data, so you can come up with a suitable name for your data under which it appears in OpenBIS. So the configuration file stores all the access information that you need, and it's in config parser format. You need to set this up once, so we need to specify the OpenBIS server, and we also need to configure the S3 storage, and essentially the web service under which the S3 storage can be reached, and your password and tokens. So once you start the Streamlit app, you will be greeted with this start screen. Here we are on the first one. This is the Hello PY. You enter your OpenBIS ID token, the first field that logs you into the OpenBIS service, and then you can also enter the S3 storage credentials in the second button. Then you move to the second page where it says Link Data on the navigation pane on the left, and then you have to follow two more steps. First of all, you choose the dataset type in the experiment to link the data to. So the dataset type is, for example, SEM image or TM image or atom probe data or whatever it is. And you can choose now the experiment that you want to link to in OpenBIS. Once you log into OpenBIS, this little web app will query all the experiments that you have access to and will give you then a drop-down list. And then, for example, you choose your dataset type, right? So in this case, we choose an electron microscope image, SE, and we use our experiments. We choose our experiments, and here, as I said before, once you log into the tool, it will query OpenBIS and give you a list of all the experiments that you can link your data to. And then in the next step, you upload the data. So before you do that, you enter a name under which it will be appear in OpenBIS, and then you can also add an additional prefix that will be added to the file when it is uploaded to the S3 storage space. If for this specific file type and metadata extractor already exists, then this one will be shown to you in another drop-down list. So remember that previously we've chosen electron microscope image, and here we've already have 3 metadata extractors available, so you choose the appropriate one, and then you can upload the files. Note that first the files are all uploaded to the web server where you're running this little tool on. So if you run it in your institute, you need to have sufficient storage space to first sort of stage the file locally to that web server, and from then on it's moved on to the S3 storage space. If that doesn't work for you, you will need to revert to the Python script where it is uploaded to S3 directly. Of course, you can also see what kind of data is already there and download the data from here. So you go on Show Files on the navigation pane on the left. Again, you can choose your experiment. So here I get a list again of all the experiments that I have access to. Let's take our demo experiment again. If I choose this, I get the list of all the files that are available. And you can see here our test upload. This is what we've done previously. Has been uploaded. It's of type SE electron microscope image. Kind says that it's a linked file in OpenBIS, and registration day says when I've done this. And you can also see the cosine S3 path. So if you want to go to the cosine web interface, you can find the file under this ID string there. You can download the file here, so you select it and click on Download Data. Again, this file is first staged to the web server where this little app runs. So when you set up the web service in your institute, you need to bear this in mind. And if you have multiple files, they will be compressed into a zip archive first. So maybe it depends on what kind of files you have. If you have very large files, it's probably best to download them one step at a time.